Welcome to homework.
We're going to say that h would be the height of the toroid. We're going to say a would be the inner radius, and b would be the outer radius. We can then say that it has a square cross section, so h would essentially be equal to b minus a, or we can say 0.02 meters, given that a is equaling 0.10 meters, b is equaling 0.12 meters. We can then derive the flux using equation 2924. So we can say the flux would be equal to this, the integral from a to b of the magnitude of the magnetic field times the change in the area. This would be equal to the integral from a to b times mu naught, the magnetic permeability in a vacuum, times Ni divided by 2 pi r multiplied by h dr. This is going to be equal to mu naught NIH divided by 2 pi multiplied by the natural log of b divided by a. And so we can then say that we can use equation 33 to find the self-inductance. L would be equal to N times the magnetic flux divided by I. This is equaling mu naught N squared H divided by 2 pi. Of course, the i's then cancel out, and then this would be multiplied by, again, the natural log of b over a. We can then say that the inner circumference L this would be equal to 2 pi a, or we can say 2 pi times 10 centimeters. This would be approximately equal to 62.8 centimeters. We can say that the number of turns of the toroid would be n. This would be approximately equal to, again, 62.8 centimeters divided by 1.0 millimeters. And this is equaling 628 turns. Therefore, the self-inductance would be equal to, again, mu naught N squared times H. This would be divided by 2 pi times the natural log of B over A. And this would be approximately equal to 4 pi times 10 to the negative 7th henries per meter. This would be the magnetic permeability in a vacuum. This would be multiplied by 628 quantity squared, multiplied by 0.02 meters. This would be divided by 2 pi, and then times the natural log of 12 over 10. Okay, and at this point we find that the self-inductance is going to be 2.9 times 10 to the negative 4th henries. So this would be our answer for part A. We can say for part B, we're going to note that the perimeter of a square is 4 times its side. Therefore, the length here of the wire, this would be length of the wire would be approximately equal to 50 meters in this case. So the resistance of the wire, R, would be equal to the length times here, the resistivity, essentially. This would be equal to 50 meters multiplied by 0.02 ohms per meter. And this is giving us approximately 1.0 ohm. and we find the inductive time constant. This would be equal to the self-inductance found in part A divided by the resistance R. This is equaling 2.9 times 10 to the negative fourth henries divided by 1.0 ohm. And this is giving us 2.9 times 10 to the negative fourth seconds. This would be our answer for part B. Again, the inductive time constant tau sub L. That is the end of the solution. Thank you for watching.